So now let's have a look at another important algorithm which is used in order to perform clustering or groupings of data. And this is a very powerful algorithm again, and the basic concept is very much similar to our previous algorithms, but it can perform very well for a numerous sets of data. So it is known as Cohen's neural network because it was proposed by Cohen, and but most commonly used name for this algorithm is SOM, and which represents the self-organizing maps. So as you can derive from the name that we will be creating maps, and those maps will basically self-organize themselves in order to make clusters of data. So we will have a look at the motivation of this algorithm, then some introduction to self-organizing maps, then we will look into the detailed algorithm, and we will also see an example in order to have understanding of SOM algorithm, and then we will also see an application which uses SOM in order to perform clustering on a data set. So the problem is how to find out semantics relationship among lots of information without manual labor. So you know that if we have a large amount of data set, or we have a large set of features, and if we want to if we want to develop an understanding, or we want to have an understanding of the semantic relationship between them, then in order to do this manually can be a very time consuming and hectic task, right? So as you can see in this figure, like if we have some large amount of data representing different values, which can be from a similar domain or maybe from different domain, and if we want to establish a relationship or a semantic relationship between them, then manually doing it will be very time consuming and resource intensive task. So in such kind of situation, we tend to use these kinds of algorithms such as self-organizing maps, which can perform this task for us automatically. So how do I know where to put my new data in if I know nothing about information's topology, right? If I don't know the basic characteristics or the basic connections between the existing data sets, then it will be difficult for me to put my new data set or my unknown instance to the existing data. When I have a topic, how can I get all the information about it if I don't know the place to search them? So another problem which I can resolve through this algorithm is that, for example, if I have a new topic and I want to have all the information related to a specific topic, and if I don't know how to search them, then this can be a very problematic thing for me. So as I told you earlier, that self-organizing maps were basically developed by Cohen, and that's why it is also known as Cohen neural network, and it was developed back in 1982. Neural network algorithm using unsupervised competitive learning. So as we know that we are in the unsupervised learning domain, and for SOM we also don't have the labeled data set, and the learning is performed based on the computation of its surrounding neurons, primarily used for organization and visualization of complex data. So the initial usage of self-organizing maps was to visualize the patterns present in the data set. So because if we have some complex data set, then its visualization can help us to understand or can have an abstract level knowledge of its attributes. Neurons are arranged on a flat grid map. So in our self-organizing maps, we basically make an arrangement of the neurons in a flat grid or a map or a lattice, or you can also say a two-dimensional array, right? So we have, in simple words, you can say that we have a matrix and we arrange our neurons on that matrix. There is no hidden layer. So the important thing between this neural network and the previously studied neural networks is that we don't have any kind of hidden layer present in a SOM. So in a SOM, we have only two layers. One will be the input layer and one will be the output layer, and there will be no in between or hidden layer between them. Each neuron on the grid is an output neuron, and since we have only two neurons, so the neurons present on the grid or the matrix will be acting as the output neurons. Topological relationships within the training set are maintained. So we try to maintain the relationship or the topology within the training set. So the basic idea behind a self-organizing map is that we make a two-dimensional array or a matrix or a map. So you can call it with any name, but the basic idea is that we need to create such kind of grid and we basically randomize it. Then we present training data to the map and let the cells on the map compete to win in some way, right? So we basically create a competition between the cells or between the neurons present on that map or grid, and we basically see that which neurons are basically winning among other neurons. And the most common way to judge this is basically by using Euclidean distance, which we have already seen before. Then we stimulate the winner and some friends in the neighborhood, right? So this is basically the update part of the weight matrix, because similar to other neural networks, we need to update our weight matrix so that we can move towards the convergence. And in a SOM, we basically update the weight matrix by simulating or stimulating the winning neuron and some of its neighboring neurons, like we have seen in KNN. And we repeat this step for a number of times, and the resultant is a two-dimensional weight map, right, or a matrix which contains the weights of the winning neurons, and you can use them for clustering. So here is a basic diagram of a self-organizing map, and you can see that we have only two layers here and we don't have any hidden layer in between. So this is my input layer, this is my output layer. My input layer contains three neurons, x1, this can be a number of input neurons ranging from x1 to xn, and similarly my output layer can also have a number of neurons or cells ranging from y1 to ym, and we basically create a competition in between, and we try to figure out the winning neurons, and then we adjust our weights in order to create the resultant weight matrix. So as you can see in this figure, that we have the neurons in the output layer, and the output layer neurons are basically arranged in a map. So we have a 2D map here, or a matrix here, or a grid here, and this output layer, all the neurons present in the output layer are basically arranged accordingly on this grid map. So we have 2D array of neurons in the output layer, and we have the weighted synapses, right? So you can see that for all the connections, because we have our input layer here and we have a number of neurons in the input layer, and this represents the set of input signals, right? So each input layer or each input neuron is basically connected through a weighted connection or a weighted synapse to with the output layer. So this phenomena is very similar to a fully connected neural network basically, and the target is to basically adjust the values of these weights so that we can have a resultant weight map or a weight matrix which can be used for the clustering or grouping of all the unknown instances.